What am I supposed to do first? Okay, so I subtract 27 from both sides. Thank you. So I have x squared plus 6x minus 27 equal to 0. Of course it is.
And then you can factor it out. And you get x plus 9 and times x minus 3.
Plus 9 and minus 3. Okay, and he's right because we were asking ourselves what were two things that added to 6. It'd be 9 minus 3 is 6. Two things that multiplied to a negative 27. 9 times a negative 3 is a negative 27. So he is correct. So we factored it, but we've been stuck on quadratics lately. Looking at this, where would our two zeros occur? Rookie mistake. It's not 9 and negative 3. It's negative 9 and positive 3. You know it's the opposite signs. You know that. So the roots or the zeros would be at negative 9 and positive 3. You've made that mistake. You're never going to make that mistake again, especially considering now that there is a test on Friday. Last week we were working on this yellow handout. Let's go back to our yellow handout now. We filled in. Mine's super got a lot of junk going on. We took notes on standard form and intercept form. Standard form is nice because you can see certain things automatically. What can you automatically see when you're in standard form?
The A, B, and C.
I see that. What would that help me on the graph of the quadratic?
The roots, the zeros, and
The roots and the zeros you'd have to factor. So there's a little work, not much work, but a little work required. What can you just see with your eyes?
you can see
Your y-intercept.
You can see the y-intercept because you just cover up the parts with the x's. The y-intercept is the c. You can see the y-intercept. Ashanti is right. You can easily calculate those roots and zeros by factoring. And then Maggie said one other word that I am going to write down. And what else can you see, Maggie? Yes, you actually do have to calculate it because it's negative b over 2a. But no other form is there like this is the axis of symmetry. This is it. Or so we think. Okay, so there's the standard form. Then if we go to intercept form, and it kind of says it in the name, what can you see automatically in intercept
the
form?
roots, the zeros.
You can see them, but please, for the love, they're the opposite sign of what you think. So our roots are at negative 1 and positive 3. Everyone makes this mistake. You are not the first. You are not the last. You can see the roots. And really, if we use those roots, we can kind of see the axis of symmetry. I could write that if I wanted to. However, to find that vertex, it requires a little effort. So today, vertex form, it kind of implies what's about to go down. What can you see in vertex form? Obviously, you're going to be able to see the vertex. If you can see the vertex, what else can you see? Automatically, you can see that axis of symmetry because the x-coordinate of the vertex is going to hit that axis of symmetry. Our vertex is the only point on the parabola that touches the axis of symmetry. And then you're going to be kind of annoyed because you've seen a form like this before. It reminds me of when we did LTF and we did point slope form. This looks really similar. A x minus h squared plus k. Our vertex is at the point h, comma, k. The A is still that number either making me fat, skinny, open up, open down. The H and the K are the vertex. What's weird about this equation? Tell me what's look. Don't turn it. What's weird about this equation? What's annoying?
The power?
Well, all of them got the power because they're all quadratics.
What's annoying? The adding.
What's annoying to me? Maybe I'll just show you what's annoying to me. Why does this one get to be minus and this one get to be plus? That's annoying. So with our roots, remember how it was minus, so it was opposite signs? In the intercept form, it's a minus, so the roots end up being the opposite sign. My root is at -1, my root is at +3. With vertex form, it ends up being the opposite sign for the h. So my root is at -2, my vertex, good grief, is at -2, -5. So if you want to make a note, it ends up being opposite sign for h, which is the x coordinate. So if you want to put opposite sign for x coordinate, that would be even easier to read. And why is that? Because if we were to rewrite this to look like, so the a would be 1, and then it's supposed to be x minus h, so it would end up being x minus a -2 squared minus 5. Now, are you expected to rewrite it like that every time? No, not at all. But here is why it ends up being the opposite sign. Because the form says x minus h. So for us to write this as x minus h, our h would have to be -2, and our k would be -5. And our a is 1.
Can you explain it?
Yeah. Let's just start at the beginning. Does it open up or down? Is the a positive or is the a negative? It opens up because the a is bigger than 0. Our vertex, we can read it. It's the opposite sign for the x, so it would be -2. It's exactly like it looks for the y, so -5.
Thank you.
It's the opposite sign for the x, so instead of +2, it's at -2. It's what you think for the y, so -5. So my vertex is at -2, 1, 2, 3, 4, 5. Where is my axis of symmetry? What value is my a? So how can I graph this easily?
You can use the perfect square thing.
You can. So all I have is the vertex, but since a is 1, over 1 up 1, over 2 up 4, over 3 up 9, and suddenly I've written way less work, way less math than we've been doing. We've been plugging stuff in nonstop, trying to figure out where the intercept is, trying to figure out everything. But I swear, if you could just spot that vertex, the graph will come easily.
What did you do over 3 up 9?
I thought so.
It's confident. I have a theory.
Am I going to like it, or am I going to be mad at you because it's May 1st?
Well, it seems like it's something else to use, because I don't think it's going to be that easy. Sure. Okay. I got kind of scared.
You're going to overthink it is what's going to happen. Okay, so the reason we like vertex form is because you can see the vertex. But people are going to get confused. It's the opposite sign for the x. It's exactly what you think for the y. And the reason it's the opposite sign is because in the form, it's x minus h. That's why it's the opposite sign for the x. So we're looking at example 6. Let's start at the beginning. Lord knows where let's start at the beginning. So does it open up or down? Why? Okay. And then do not overthink your life. Do not try to use that negative sign to make our life harder than it is. Our life is as easy as it looks. Where is my vertex? -2, because it's the opposite sign for the x, and then 3. So -2, 3. 1, 2, 3. Where is my axis of symmetry? Negative 2. Is the A positive or a negative 1? Is it a positive or a negative 1, or is it, if it's a fraction, we're going to be fat. If it's a whole number, we're going to be skinny. But is it anything like that, or is it going to be normal? It's negative 1. So we can go over 1 down 1, over 2 down 4. Over 3, down 9. And all of a sudden, I'm showing way less work than I was last week. That's partly because intercept form is that easy to read. That's partly because we finally understood that this counting technique sure would be useful when A is 1. And it's partially because I'm also being lazy like you, and we've spent enough time plugging in a 0 to figure out that y-intercept. If you plugged in a 0, could you still figure out for sure that that y-intercept is where it is? Well, yeah. You would end up getting negative 4 plus 1. It ends up being negative 1. Hey, that's where I was drawing my y-intercept anyway, at negative 1. So it would all end up, everything we did last week would still work. You can still plug in 0, you can still do all the things. But do you have to? No. And did we really have to do as full out as we did last week? No. If you can figure out the zeros, if you can figure out that vertex, if you can figure out that axis of symmetry, normally the graph comes out pretty easy. Okay, are there any questions about this? Then you're going to like the group activity because that's where it's even easier. Okay, Zach, give everybody one of these, please. Aaron, come get this. Ashanti, come get this. Kennedy, come get this. Riley, come get this. It's for your group.
You know what I on it?
What? Riley, Jameson, come get this. Yep. Thank you. It's mine. It's my bell ringer. I know what it is. Okay, let's look at this so you can get started, and that way you don't have to do any of this for homework, because that would be annoying. You are given lots of pieces of paper. I'm going to just start with A to prove a point. So we're given A in standard form. It's y equals 2x squared plus 4x. Now you could make life difficult, and you could go to Desmos and graph it and figure out which graph matches, but that seems kind of annoying, so let's not do that. Let's do some math first. What could I factor out of 2x squared plus 4x?
2.
A 2, and what else? And what would I have left?
X plus 2.
Okay, so which factored form graph should I be looking at? So I got my standard form equation. Now I'm looking at the factored form equations. Which factored form equation matches this? You're given lots of papers. Look through the papers. What letter? I heard it. It is I. Okay, so we had a standard form. We found our factored form match. Now we've got to find our solutions match and our graph match. To find our solutions match, we need to set each of those equal to 0. So I'll do 2x equal to 0, and I'll do x plus 2 equal to 0. What are my two solutions then? What are my two solutions then? X equals what? negative 2, and the other one is 0, because 0 divided by 2 is 0. So I need to find the one that said on the solutions pages, which one says 0, negative 2. Y, he says, is he correct? Yes. So our solutions are 0, negative 2. So that is Y. So far we were given a standard form. We found the factored form match. We found the solutions. And now to find the graph. So we've got to look at all the graphs and see which one hits at 0 and negative 2. Which graph should match? It is W. Do I expect Maggie to have the most beautiful graph ever? No. 0, negative 2. It looks like the vertex is at negative 1, negative 2. Negative 1, negative 2. I'm just eyeballing. You're handed the graph. I'm just copying. Ta-da! I am done. I found the standard form. I matched it to a factored form. I matched it to a graph. I matched it to a solution. Are there any questions about that? It seems fairly easy. What I would do is give each person a different standard form. That way they're looking to find the factored form, the graph, and the solution to match. That would be the way to get it done the fastest. Okay. Let me know if you have any questions. Get to work.